We are starting the new chapter today, and the new chapter, gentlemen and ladies, starts off, I hope, fairly easily for you. It should be an algebra review. If you noticed, the title of our notes today is Ratios and Proportions. You've seen ratios and proportions before. So as you can see on the screen, we're, once again, defining ratios for you. Remember, they are just a comparison of two numbers. You can see a ratio sometimes represented as number colon number, or you might see a ratio represented as just a fraction. In the Your Turn problem 1 that I have not yet started on the Centillo, but I will. When you enter that answer, I am going to ask that you type it in as a fraction and not as a decimal. Okay? So in problem 1, kind of refreshing our memory on using ratios, the most important thing that you have to remember in a problem like problem 1 is that ratios you're expected to have in the same, let me rewind. When you're asked for a ratio of two things, in general, it's expected that those two things will be in the same unit of measure. So if you're looking at problem 1, where it's talking about the pygmy rattlesnake's length is 18 inches, whereas the diamondback's length is 5 foot 6 inches, I'm being asked for a ratio, ladies. And the problem with the problem is that these are not the same units of measure. So the first thing you need to do is remember how many inches there are in a foot? 12. Good. So we're going to use that in order to convert the diamondback's length into just inches. Jacob, did you get notes? Okay. And make sure you get a Centillo if you haven't already. Okay, so what am I going to do to that 5 foot 6 inches in order to convert that into just inches? Multiply 5 times 12 and then add the 6. Beautiful. Okay, so the rattlesnake is 5 times 12 plus 6, which is 66. Okay, so now I have both of my measurements in the same unit of measure. Another point that I want to emphasize, and for some of you this is going to be a well duh thing, and for some of you this is going to be a well, what does it matter anyway thing, but it does matter. Please notice the order in which this is asked of you. You're asked for the ratio of pygmy to rattlesnake. And if you give it to me upside down, that's wrong. That's 5.12, meaning 5 times 12. Okay? So, since I was asked for the ratio of pygmy to rattlesnake, I take the pygmy, which was 18, I put it over the 66, and is this the answer that I would want on a test or quiz? Why not? I need it reduced or simplified, absolutely. This fraction reduces to 3 over 11, and that's the answer that I would want on a test or quiz. Okay, please take a moment, work through the Your Turn problem 1, and when you have finished, please type that answer into your Centillo. I only have 13 of you logged into my class. There's certainly more than 13 of you here. If you're having technical difficulties, then that's just you. Yes. So, problem is, this number. the your turn. Yes, and I'll type it in. There should be a fraction going on, right? Yes. No, it doesn't want to change. Wait, what do I do? Oh, you're good. Well, your answer is fraction. You're typing in number over number. Hey, I'm still waiting for a few of you to type your answer in.
I don't know it.
Your name is not up there because you've already typed your answer in. No, that was the answer to this Hey, I'm still waiting for a couple of you, but I don't want to wait forever. Okay, so you need to convert that to okay, so number over number. And then reduce it, Hey, some of you are still up there. Now we're wrapping it up. Come on, let's wrap it up, Hope. I'm waiting for you. I know that you're the only person who has typed an answer in. Okay. Okay, fantastically, our overwhelming majority entered 3 over 4. A couple of you don't know. Oh, maybe someone reversed their numbers by accident, typed in 18 over 42 instead of 18 over 24. Someone else may have typed in 6 over 8 and then realized they needed to reduce their fraction. Not quite sure where some of those other answers would have come from. Bottom line. Okay, to clarify, what you needed to do here was realize that there's 24 inches in the 2 feet tall, so you would do 18 over 24, which reduces to 3/4. Okay? Yes? The notes are a reminder, refresher of ratios and proportions. We are perhaps using ratios and proportions in a new way. Perhaps in number 2, you may not have ever seen a problem like this before. In number 2, we have complementary angles. Let's refresh our memory. Complementary angles, what's that? They add up to 90 degrees, ladies. So I have 2 angles that are going to add up to 90 degrees, and they are in the ratio of 1 to 3. So realize what happened here. Okay? Somebody had these 2 angles. He noticed that they were supplementary. He noticed that when he put them in a fraction form, it reduced to 1 over 3. Now, think about what you did in that last example. When you reduced a fraction, what did you do? When you reduce a fraction, well, yes, you're making the numbers smaller, but how are you making those numbers smaller? You're dividing by a common factor. So the problem with this problem is that we don't know what that common factor is. And last year in algebra, when you didn't know something, it was x. So we're going to think of these two angles as 1x and 3x. And you already told me something about that 1x and 3x. They add up to 90. So you see how we are taking a ratio problem and turning it into just an equation that we can solve. So we have 4x equals 90, and x is 22.5. The problem was asking us, ladies, for the measures of the angles. 1x was, in fact, one of the angles. What would I do to find the other angle? What would I do to find the other angle? I could subtract it from 90, but the idea that I want you to get is that, yes, by all means, you would take this 22.5 and multiply it by 3 to get the other angle. Our two angles, therefore, are 22.5 and 67.5. Okay, please take a moment and work through the Your Turn problem 2. This is not a CENTIO problem. This is just paper and pencil. Because it's asking for two angles. Supplementary, remember, means they add up to 180. Read the question. Gotta read the question. I got plenty up here. Oh, please, I don't want to get up the wall. I want the whole world to know when they listen to this video. Oops, doesn't really get up from the chair. Wow. How did you pay that money? How did you fix this? Okay, from what I'm seeing and hearing, take a pass. You're ready to check your answers against mine. Anything I need to clarify up here, something that you're still kind of fuzzy about? Okay, remember, thank you for bringing that up. A lot of you asked me, okay, I got that the x equals 36, but I don't know how to find the other angle. Remember, the 1x and the 4x are my two angles. So once I know what x is, I multiply it by 4 in order to get the other angle. Put on this screen. Okay, taking this kind of problem to the next level now, notice an extended ratio is basically just a ratio with more than just two numbers. Okay, so in problem 3, I have the length of the sides in a ratio of 2 to 4 to 5. I know that the perimeter of the triangle is 77. Do we see how we can use that exact same strategy in this problem here? My three sides of the triangle are 2x, 4x, and 5x. And remember how you find perimeter. You add up all of the sides. So that's going to equal the 77. Okay, so 11x is 77, and x is 7. Am I done with this problem? No, I haven't answered the question. Question was, what is the longest side? So don't give me an answer, give me a process. What am I typing into my calculator, or what am I doing in my head, because I remember my times tables? Mr. Massey. Right, realize that your longest side is that 5x. So my longest side is 5 times 7, which is 35. Okay, the next your turn is a Centillo question. However, please notice the question on your paper is not the same as the question on the board. The question on the board is asking you for the shortest side. Yes, this is a Centillo question. What's on the board? Answer the question that's on the board. Yes, the your turn problem 3. Please work through the your turn problem 3. And when you found your answer, please type it into the Centillo. Again, make sure you're answering the question on the board. Make sure you're reading the question that's on the screen. That's the question you need to answer. Not bring out long answers in an attempt to distract people. Yeah, there's a Centillo question. Answer the question on the screen. The question is asking for the shortest side. And fantastically, our correct answer is our overwhelming majority answer. And the comedian, I know who you are because you logged in, remember, in order to answer that. So that was real genius. The comedian, I know who you are. You logged in order to enter your answer in the first place. I can use it as a means of determining, yes, they are doing what they're supposed to be doing, or no, they're just putzing around and wasting my air. Oh, no, I'm so far above that. All right, on the screen, let's come back. On the screen, you see an excerpt straight out of your textbook, and it is just, once again, a reminder of stuff that is true about proportions. Let me backtrack. In case you weren't already aware of what a proportion is. Oh, do me a favor and turn those Centillos off. We're done with them for the class period. Thank you. Like I said, I will be trying to incorporate them in my lessons more and more, but for today, that's it. So, a couple of things that you can do with a proportion. First of all, realize if I have a proportion like A over B equals C over D, I can take that proportion and flip the whole thing upside down, and it's still basically the exact same proportion. Similarly, let's backtrack to something I hope you mastered last year in algebra. When you have a proportion and you're using that proportion to solve for x, do you remember how you do that? You have a proportion and you're trying to solve for x, because there's x somewhere in here. Cross multiply and set the cross products equal to each other. And we'll refresh our memory on how to do that on the next screen. Okay, so the reason why I'm bringing that up now when we're talking about what is true in proportions is, once again, if I have A over B equals C over D, one of the things that you're allowed to do is switch things across the diagonal. And that's because you're not changing any of the things that are being multiplied together. Right? So, last thing that you are able to do in a proportion, and again, I know it's kind of hard to see up here, but it is in your textbook. The bottom line is, whatever you do to one side of a proportion, you must do to the other. So if you notice, in this proportion, what I'm basically doing is adding 1 to the left-hand side. Well, that means I better add 1 to the right-hand side. Let's take a look at what we remember how to do about solving a proportion. In part A, like I said, when we have a proportion and there's an x that I'm trying to solve for, you cross multiply, set your cross products equal to each other. So in part A, I would have 3x equals 40. And then I would divide both sides by 3, and x equals, and by all means, if you realize that it's not going to divide nicely, you can leave your answer as 40 over 3. That's fine. If you went ahead and divided it in your calculator and got 13.3 repeating, that's fine also. For part B, what I really want to stress to you that you need to be careful of is distributing. So some of you might benefit from rewriting this cross multiplication as, well, 12 times 5 you know is 60. And then you know you're multiplying the 6 times the y plus 3. Some of you may benefit from writing this extra step. Okay, just so that you don't forget to multiply that 6 by everything in that part of the proportion. Okay? So, 60 equals 6y plus 18. 6y equals 42. And when we divide both sides by 6, y equals 7. Okay, please take a moment, work through the your turn problem 4. Again, you should be working through the your turn problem 4. And please note you have a quiz on Friday. Quiz on Friday. Okay, from what I'm seeing and hearing, you're ready to check your answer against mine. Please do so. And if there's part B, absolutely. Okay, if you got, yeah, notice I have both answers. Okay, once again, do I need to go over part A or we're good on that one? We're good. Okay, part B, remember, you have to use the distributive property. Be very careful. So I have 15m equals 3 times m plus 1. And when I distribute, I have 3m plus 3 equals 15m. Subtracting the 3m, I have 12m equals 3. And if you said that you got 4, you're forgetting that you need to divide by the number that's being multiplied by the variable. What's being multiplied by the variable? 12. So that's what I'm dividing both sides by. 3 divided by 12 is not 4. 12 divided by 3 is. That's a huge difference. Okay, so m is equivalent to 1/4, or if you typed it into your calculator, 3 divided by 12 would give you 0.25. We have from this screen what we need. Okay. Last kind of problem that I want to make sure to expose you to, because you'll see something like it in your homework, which will be due, yeah, I was going to make it due Thursday, but that's not going to work. Friday. Okay, at the beginning of class before our quiz. Yes, ma'am. Then you can make up the quiz when you get back. All right, so in problem 5, I don't know why they have this diagram there, other than to kind of start weaning you into the concepts that we're going to be dealing with in this chapter. The diagram doesn't mean anything to us right now. What's important to us is that this proportion that they've given us is true. And what they're asking us to do is notice that something has changed in my new proportion, and they're asking us to fill in the blanks. Yes, ma'am. No, it's here. Got to conserve paper. Okay. All right. So what I'm asking you, ladies and gentlemen, is what's on the other side of the equal sign now that the y has moved to under the x? One person, please. What's on the other side of the equal sign now that the y has moved under the x? One person, please. Oh, bold and brave. Wimpy mathematician. Yes, Gabby. What over 9? 10 over 9. What I hope she noticed is where this y came from. It used to be diagonal to where it ended up being. Remember that I said previously that in a proportion, you can switch stuff across the diagonal. So the only difference between this proportion and this one, now do you see that the y and the 10 got switched across the diagonal? Okay? There is a your turn, but once again, in my persistent efforts to incorporate technology and bring you into the technology, I would love if someone would click and drag out of my, let's call it a number bank instead of a word bank, into the appropriate proportions. If I could get a volunteer to come up, Brittany, click and drag just the answer for part A. Fantastic, thank you. Someone else, please, for part B. Someone else come up and click and drag for part B. That one's a little bit different. Look at what happened to, again, here's the original proportion. Something has started to happen to it. I'm asking you to finish making it happen. What's on the other side of the equal sign? Come on up and click and drag. You're so eager to click and drag stuff on your phone. Click and drag it. There she goes. Bold, brave. No room for wimpy mathematicians here. Oh, it, bounced it back out. It didn't like it. It's wrong. There, like that one. And this is what I want you to notice. On the right side of this problem, notice what happened. I took that 7 and I added it to my numerator. So I'm going to do the exact same thing with this fraction. I'm taking the denominator and adding it to the numerator. Okay, there is a daily quiz. I'll be activating it momentarily. Go take the pass. Give me a moment. Don't log in yet.